that then, because and again we can go to R4 also one more time just to verify that okay, it's not, we could verify clearly we are not seeing any of those IP prefixes coming from AS100 on the R4. So how do we really solve that? So that's the reason now the question comes on, or that's the reason now we need to go ahead and create a BGP session between router R1 and an R4. Because router R1 and R4, they are both within the AS1, we would end up creating an iBGP session. So once you have an iBGP session, so let's go ahead and configure an iBGP session and then we'll see what really happens. So we are on router R4. Let's go ahead and configure an iBGP session towards the router R1. So we go into router BGP1 and we'll say the neighbor is 10.0.0.1. This is the R1's loopback address. So we'll just say remote AS is 1. And for this neighbor, we are using update source as the loopback 1. And let's just simply go ahead and end this. And now let's go ahead and configure our router R1. We can do show iBGP summary here, and we could see that we do not have a session right now. So now let's go ahead and configure. We go to router BGP1. We'll do the simply neighbor 10.0.0.49 with a remote AS of 1. And again, the update source would be loopback 1. And let's go ahead and give it a few seconds, and you could see now a BGP or iBGP session has come up between our router R1 and R4. Now, because now R1, because of this iBGP session, now the R1 is kind of has a direct connection between R1 and R4. And the BGP split horizon rule, we have kind of, work around it basically. Or one of the reasons that's why we need a full mesh of iBGP session is required really for the proper iBGP update propagation. We saw that when we didn't have this neighbor relationship up between R1 and R4, the BGP split horizon rule was really blocking those updates. And now if everything is good, let's verify that BGP, yep, we have a neighbor up and we kind of, it's been up from last 51 seconds. These are the number of prefixes sent and received. Now at this stage, we can go ahead and take a look at and see, hey, what are the routes that R1 is advertising towards the router R4. So let's go ahead and take a look at 49. And now we could see magically that, hey, all of these prefixes that we are receiving from our AS100 are also being advertised towards a router R4. So we can see all these external prefixes, these external BGP prefix, the external prefixes that we are receiving from this external BGP peer now are also sent to the internal. Now we can go to the router R4 and we can take a look at verify, what do we see here? The neighbor relationship is up. Previously, before this session, there were no prefixes. Now just rerun the same command and take a look at. Now we could see that now router R4 is also receiving these routes from the router R1. Okay. Now as I mentioned earlier, in this demonstration or for this lab, I went ahead and removed all the iBGP session. So we'll go ahead and configure iBGP session between router R2 and R3. Though on R2 and R3, we do not really need because they do not have any external neighbor connected. But just for the consistency's sake, we'll go ahead and finish that configuration anyway. So we'll go to router BGP neighbor. So on R2, we are configuring a neighbor towards R3 and vice versa. So neighbor is 10.0.0.17 with a remote AS of 1, and simply again the update source that is being utilized is loopback 1. Right down on R2, and let's go towards R3. We'll do the same thing with our BGP1 with a neighbor IP address of 10.0.0.30 with a remote AS of 1, and again the update source would be the loopback 1. and we could see that the neighbor relationship has come up. Again, this was not needed, but we just wanted to make sure, okay, hey, what are the things which are working. Now, if you remember from our topology, the router R4 has an iBGP session with our AS300. Now, we just verified that router 4 is now receiving these external routes from AS100. If everything is good, then we can take a look at and see what router 4 is now advertising or sending to AS300. We can go to that router, or we can check from the R4's perspective itself. So let's go ahead and verify that, okay, BGP neighbor, and we know the IP address on that side is 172.16.34.34, and we are again interested in taking a look at the advertiser. So what it shows, okay, hey, there are only a total of 4 prefixes, and if you see, none of these prefixes contains the external prefix that we are receiving on router R4 from AS100. None of these prefixes are being sent to the AS300. Now, why the router R4 is not sending any of these prefixes to our AS300? But before that, we need to really solve this thing here where we know that, okay, hey, it really says a valid route. It says an internal route, but it doesn't say the best route. So now what is going on, and let's take a look at and see what really is happening, what's going on with these particular routes. We could really see, okay, hey, that for these prefixes, this is the next hop, and they are coming from the AS100, all good stuff. Now let's take a look at this BGP route for 10.0.1.0/28 here. So now we are trying to take a look at more detail. So what it says, okay, hey, this is the BGP route entry for this one. If you really take a look at this 176.11.11, this 11.11 is nothing but our next hop to reach this particular IP prefix. And it clearly says, okay, hey, this IP prefix is right now inaccessible. So this output, what this result or output really shows that, the next hop that is being advertised to reach this prefix or route is not accessible. And because of this inaccessibility, the route is not really marked as a good route. And because it's not marked as good route, it is not advertised towards the external BGP peers, because they do not have any way to reach that particular network. We can verify that by looking at 172.16.11.11, and it clearly says, okay, hey, subnet is not in the table. So on the router R4 has no route towards this in its routing table. So it has no way of reaching or knowing how it needs to go ahead and resolve this. Okay, but let's go back and take a look at on R1. We know the R1 is the one who advertised or who received these routes from AS100 and was responsible for advertising this towards all the rest of 3 iBGP peers, R2, R3, and R4. Now, does R1 is R1 able to resolve this? So we can go ahead and take a look at the same thing. So iBGP 10.0.1.0/28. And we could clearly see, okay, hey, it says, yeah, it's receiving from this one, that it has a valid next hop for this one. But some of the other routers, the other iBGP speakers like R2, R3, and R4, they have no way of reaching or resolving this particular next hop. And that's where we have a couple solutions to fix this problem. We could simply, there are many ways to, there are primarily 2 ways that we're going to go ahead and take a look at and solve this particular problem. One of the ways, any time you see this next hop, which is a BGP attribute, this next hop attribute is really set by your far end of the iBGP session primarily. Okay, and all iBGP peers must be reachable. So that's how they're going to go ahead and resolve. Now these iBGP next hop can also be announced using the iBGP. So one of the way we can go ahead and do is, we can go ahead and simply redistribute the interface which is connected into the iBGP, and the interface that is connected between those two routers, those are our edge routers. We can go ahead and take that and redistribute that. That could go ahead and solve the problem. But when you're doing that, we need to make sure we configure them as a passive interface. Now, when you go ahead and do this approach, the routers are going to use the recursive routing or recursive routing mechanism to really determine how they need to forward this IP packets towards those external destinations. And for that, the BGP routers are going to take a look at the routing table, and that's how they're going to go ahead and check how would they need to go ahead and resolve this next hop address, and based on that they can go ahead and make use of this one. Another thing that we need to remember, we can go ahead and redistribute, the recursive can work, but to get the recursive routing to work, the router basically needs to resolve all the possible hop references. All those references are resolvable or reachable. Now, when you are doing the redistribute, we know that on those edge router you are using a particular subnet. So we can go ahead and use the redistribute command with the connected, and we can also go ahead and make use of the subnet keyword while doing so. That's one of the approach to go ahead and do that. But remember, whenever, like any time when you work with these things, some of these things have their own drawbacks also. Yes, it will go ahead and resolve, fix some of our problem, but it can bring up another problem. Like any time when you do a redistribution, and depending on the IGP protocol that you're using, some of these routes could appear as external routes, and each IGP, like OSPF or ISS, has a different way of handling some of these, and they have certain limitations around those. I'll not go ahead in those, but yeah, you need to keep in mind when you are trying to redistribute, what are the things to do. Another thing, if you really do not want, route distribution, if not really desirable for whatever reason, we could also go ahead and, as I said, include the subnet on the eBGP session. And for that, we can go ahead and simply use the network command. So now let's go ahead and solve this problem and then see what we can go ahead and do that. So what we'll do that, we know that R1 is the router, which is our edge router on the AS1 side, which is connected to the AS100 on ISP1 side. So we could just simply take that subnet, which is being configured on the interface between ISP1 and R1, and we can go and redistribute that subnet, into our OSPF routing protocol. If you remember, as I said, we are running the OSPF routing protocol within the AS1, but right now we do not have anything configured. We can go ahead and, as I said, we can go ahead and configure this thing and advertise towards the rest of these routers R1, R2, R3, and be done with it. So let's go ahead and take a look at and see how we can go ahead and finish that. For that, I'll be using a route map. So let's go ahead and use a route map, and we can say from ISP 1 or whatever, and let's say permit 10, and then we just simply say the interface that we are interested in matching would be the interface which is connected on the other side, and the OSPF process that we are running is 1, and we'll just simply say redistribute. And when we do redistribute connected, as I said, we can use the subnet keywords, consider subnet for redistribution into OSPF, and that's what we want to use. And with that, we can go ahead and specify a route map, and the name of the route map that we had configured is from ISP1. And let's go ahead and do that. Now, what we just did, we took the subnet that was configured between the ISP1 and R1, and we went ahead and redistributed that. And if everything is good, if the redistribution worked, then we should be able to resolve which was the previous next hop, which was inaccessible. So let's take a look at earlier when we ran this show iBGP command, it clearly said, okay, it was inaccessible. Now let's go ahead and take a look at and see what happened to this particular route. Now, if you see, magically it really says, okay, hey, that this particular subnet or IP prefix has now a valid, basically the next hop, which is 116.11.11. And again, it is learning this from 10.0.0.1, which is nothing but your router R1. We could go ahead and take a look a little bit more detail for that particular next hop now. And here it really says that, okay, hey, now I know how to reach this particular subnet, and to resolve this particular one, I am using the OSPF1. And this is one of the interface that is being utilized, because if you remember, the R4 has two connections, one towards R2 and one towards R3. So it is going via one of this interface, and this seems to be our valid one at the moment. Now R4 knows how to resolve this. Now let's take a look at our iBGP table again. So now if you take a look at on the BGP table, wow, magically, now if you see, okay, earlier we had these as the valid and internal, now they are also the best route. So that means now this R4 knows how to really resolve or reach these particular IP prefixes, because we went ahead and fixed the problem of their next hop, which was inaccessible earlier. Now if everything is good, our R4 knows how to reach this thing. Now we can go ahead and re-verify on RAR R4 what are the routes that R4 now is going to advertise its iBGP peer, which is towards